All right. Good afternoon. So today we're gonna do a little demo of some of the stuff on the law of sines. And as hopefully if you watched in the Khan Academy videos, the law of sines is a neat little trick that was developed actually about over 1,000 years ago by Persian mathematicians, and it allows you to figure out angles and sides in any triangle. Okay, so normally with trigonometry that you're used to, it's for figuring out angles and sides of right triangles. But if we can use things like the law of sines and the law of cosines, this actually allows us to extend this to any triangle at all to figure out angles and sides. Okay, so I'm just going to do a couple examples of the stuff that you will be seeing in the Khan Academy there. So, all right, let's get to it. First of all, the law of sines is really very simple, okay? So you start with any triangle at all, okay? It does not have to be a right triangle this time. And we'll call this, well, here, let's use the same format they use. So we'll say this is angle A, this is angle B, and this is angle C. And then across from each of these, okay, kind of in the same way as you're used to when you're finding the opposite side in a right triangle, imagine like if you shoot a laser beam kind of out from each of those. That's the opposite side. And so we'll call that side little b, this one side little a, and this one side little c. So you see that the sides are opposite their corresponding angles there. Okay? The law of sines is really actually very simple to remember. All right? It's basically saying that there's a common ratio between the sines of these angles and the lengths of their opposite sides. So what we have here, the rule comes out to the length of side A divided by the sine of angle A is equal to the length of side B divided by the sine of angle B. And likewise, the length of side C is equal to the sine of angle C. Okay? So this relationship between the sides and the sines of the angles is true for any triangle out there whatsoever. And it's pretty useful. Okay? All right, so remember this, and we'll go do a couple of examples here. Okay? Leave that up for just a second so you make sure you can write that down, but there it is. Okay? All right. So now let's do a couple of little examples here. Okay, so first one I'll do comes from your homework here. You're given a triangle, and again, do not, even though they might look like right triangles on some of these figures, do not assume that these are right triangles. And again, the beauty of this is that it works for any triangle whatever. Okay, so we're going to label these sides A, B, and C. I'm sorry, angles A, B, and C. And then they give us that this angle A is 23 degrees, this angle B is 71, and this side BC is 7. And they're asking us to find side AC. Okay? So the way we set this up, okay, we know that the ratio is the same between all the sides. So I really just set this up, okay? The side little a across from angle A. So I have 7 divided by the sine of the angle across from it, sine of 23. Now this is going to be equal to the side length AC. I'm going to call that side B, little b, okay? Side little b divided by the sine of the angle across from it, 71. Sine of 71. Okay. Now I have a common ratio between these sides and the sines of the angles across from them, and I can figure out the length of side B. So really from here, it's all just kind of plugging these into a calculator and rearranging a little bit. So this just going to replace these. The sine of 23 equals about 0.39, and keep that B there. And the sine of 71 is about 0.95. Okay, now all I have to really do is get B by itself. which just means multiply by 0.95 on both sides. So 7 times 0.95, sorry, I'm doing a calculator over here, is 6.65 over 3 still divided by 0.39 equals B. And then I'm just going to do 6.65 divided by 0.39, and that equals 17.05. 17.05 equals B. Okay? They do, on Khan Academy, they're asking you to round this to the nearest tenth, so this would be 17.1. I will warn you, if you are doing some of these and you're really sure that you're getting them right, but Khan Academy is telling you wrong. Sorry, it's one of those stupid things about Khan Academy. It's a good chance that it's just simply a rounding error, that you're doing everything right. My advice is don't round. When you put in the sine of 23, sine of 71, etc., that in there, don't round while you're using those things. So like use your calculator skills, do 7 times sine of 71 and then divide it by the sine of 23 in like 2 separate steps there. And just try not to round those signs. If you do it, it probably should give you the exact right result, but there's a little bit of, it could just be a rounding error before you freak out. Okay, so try doing that. All right, let's do one more of the other kind of problem that you'll see in this group of exercises here. Okay, so this one is, say, again, before we were given an angle sorry, 2 angles and a side. This time we're going to be given 2 sides and an angle. Okay, so same idea here. Okay, so we're given, say this side is 6, this side is 7, and this side is 47. Okay, and they are asking us to figure out this angle right here. Okay, we'll call that C. And then what's it? A and B, although that doesn't really matter too much. Okay, so we're trying to figure out this angle right here. So once again, I'm just going to set this up. Okay, so I know that the ratio of the side AC here, side B is 6, and the angle across from it is 47. So I put that in as 6 over the sine of 47 equals 7 over the sine of angle C. 7 over the sine of angle C. Okay, now it's all set up. Now we just have to do some rearranging. And again, once you notice here, this is why I always keep hassling you about solving for something in the denominator. That's what we have to do. We can do a little shortcut here, though, okay, to not have to worry so much about some of this stuff. Because I have 2 ratios on each side, it's very easy, actually. Just flip both sides. So this becomes 6 over, oops, I'm sorry, screwed that up. Sine of 47 over 6 equals the sine of C over 7. Okay, so that makes it a little bit easier. Now the variable is in the denominator that we're looking for. Okay, so now again, multiply by 7. 7 times sine of 47 divided by 6. That's all we're doing here. Okay, so the sine of 47 is about 0.73. 0.73 times 7. Let me use my calculator. Is about 5.11. Divide that by 6 equals the sine of C. Okay, 5.11 divided by 6 equals 0.85. So 0.85 equals the sine of C. Now here, the one thing that's a little bit different about these problems is I want to figure out what angle C is, all right? So here, what comes in? Obviously, inverse trig, all right? So we're saying the angle whose sine is 0.85. I'm just going to jump right over here just to save a little space. So that, remember, this is where we use the inverse sine. So C equals the angle whose sine is 0.85. Make that get a little less messy there. All right, the angle whose sine is 0.85. That's what inverse sine really means. So then once again, I'm just going to pop this into my calculator. No one would ever expect you to be able to know this on your own. So inverse sine of 0.85, and we get about 58 degrees. C equals 58.2 degrees. Now again, I haven't actually 100% double checked this on Khan Academy. If this is a tiny bit off or it gives you the wrong answer, chances are it's a rounding error. Don't freak out, okay? So I'm trying to keep the numbers small so I'm not writing out a whole bunch of different digits, but don't lose it. Just try again. You'll be all right. All right. All right. That is about all there is with the law of sines. See you next time.